All right, another maximization question. This one not talking about area. This one gets kind of crazy, so we got to lock in for this. The annual yield per walnut tree is fairly consistent at 140 pounds per tree when the number of trees per acre is 40 or fewer. For each additional tree over 40, the annual yield per tree for all trees on the acre decreases by 2 pounds. So this number decreases by 2 pounds for due to overcrowding for each additional tree over 40. So it's kind of backwards how we look at this, but um, the number of walnuts produced is lower because of overcrowding. Okay. How many walnut trees should be planted per acre to, and here's the key, maximize the annual yield for the acre. This is what we are maximizing. Okay. And what is the maximum number of pounds of walnuts per acre? Okay. So when we talk about how many walnut trees should be planted, okay, that is, and we're maximizing the yield. So if we're maximizing the yield per acre, okay, now what do we control? Okay, put yourself in the shoes of the walnut farmer here. What can you control? You can control the number of trees that are planted, right? So if we make X in this case the number of additional trees planted, okay, we know what the yield is going to be. Okay, we know what the yield is going to be. If we have 40 trees, you're going to get 140 pounds per tree. That's easy, but we can mess with that according to X. Okay, so the yield that you're going to get is determined by, you take the number of trees, right? This is just simple calculation of uh, production. Take the number of trees, multiply the number of trees by the pounds of walnuts per tree, and that's going to get your overall yield, which is what we are trying to maximize, right? If I have 20 trees or 40 trees and they produce 140 pounds per tree, 40 times 140, that's going to tell me what they yield, right? But we mess with that by adding additional trees. And that's our control variable. That's our independent variable. So we know that there are 40 trees on the acre right now, but we can add a certain number of trees, right? The more trees you plant, the more walnuts you get. But at a certain point, when there's overcrowding, you get less, right? So if we add X more trees, okay, what happens to the pounds of walnuts per tree? Well, it was 140, but what happens, right? That number decreases by 2 pounds due to overcrowding for each additional tree. So this number decreases by 2 pounds, okay, for each additional tree. So every time I add a tree, I have to decrease this by 2. So if this is 2, this is actually 4. If this is 3, this is actually 6, right? So we're multiplying 2 times the number of trees because it decreases by 2 pounds for each additional tree over 40. So this is our equation that we are trying to maximize. And again, plugging this into a calculator isn't going to work well into a graphing utility. So we have to excuse me, expand this into our quadratic function. So we're going to FOIL here and get our numbers right. So 40 times 140 is 5,600. 40 times negative 2x is negative 80x. X times 140 is 140x, and x times negative 2x is negative 2x squared. Okay, so our function, if we write it in general form, would look like this. And this is the equation that maximizes our yield. Okay, this is what produces the yield in the grove, right? In the entire place where the trees are planted. All right, and this is based on X, which is the additional number of trees. Not the total number of trees, but the additional number of trees. Okay, I could have written this based on total number of trees. Then this would just be X, but I would be changing what this is over here. So there's more than one way to really look at this problem, right? So from here, if we want to maximize this, we go to our graphing utility, negative 2x squared plus 60x plus 5600, and there goes our graph, right? Gone. Even if we go to our smallest window, so what do? We zoom out, we eventually start to see this, and then because I'm in Desmos, I'm just going to drag and drag and drag until I get to that very top point, which is right here. Okay, and what do we have? We have an X value of 15 and a Y value of 6,050. Okay, so we know that our maximum, sorry, let me give myself some more room here. So we know that the Y value is, what was it, 6050 at X equals 15. So 15 additional trees, right? They want to know what is the maximum number of, or I'm sorry, how many walnut trees should be planted per acre. This is the additional number of trees. So this isn't actually the answer, right? This is additional to the 40 that was that threshold before, right? So therefore we have a total of 55 trees when we add 15 to 40. So at 55 trees, the yield is 6,050 pounds.